see and apply. If you don't see, you can't apply. So observe them. I'm going to make them so practical so that you can observe them and apply them in examination. Good. So let's go through the process. Good. This is about a circle, as the name sounds. Circle theorem. It's about circles. You know what a circle is. Good. As you can see a line passing through the center of the circle over here, right? At the center, there's a line passing through the center. What name is given to it? What is it? Diameter. Diameter. It divides the circle into two equal parts or two equal halves. So what does it mean? Each part is equal to 180 degrees. That's the angle. And when it's divided into 4, then each part will be equal to 90 degrees, as we did from angles. We explained from angles. Now, we know the line from the center to the circumference of a circle, right? From the center to the circumference is also referred to as what? Radius. That is the radius, right? So the radius is half of a diameter. So if you want to write it mathematically, you can say radius equals half diameter, right? Or you can say diameter equals twice of a radius. I think it's the same equation. Change your subject here. Now, they speak. For circuit theorem, we are going to look at 3 basic things. Let me finish the part, then we go and talk about that. This is a chord. This line also connects from circumference to circumference. But remember, this one does not pass through the center of the circle. That is very critical. That you should remember. It doesn't pass through the center, but it's also from circumference to circumference, giving you a chord. That is a chord. It also speaks. It has a special property. So the diameter has a special property, then the chord also has a special property inside the circle. We will look at that. Now we know that these are segments. When you have a portion demarcated by a chord or a diameter, it's a segment, right? Demarcated by a chord is a segment. You get it? And the side demarcated by the diameter or radius or radii is also a sector. So you can get this sector. Are you okay? Good. So this is a sector. Then the center is already known. This is an arc. A portion of a circumference. The whole circle here, that drawing, that circle here, is what? This line making the circle is what you call what? An arc, right? So this portion is an arc. A portion of the circle is an arc. So, or we can also say it's a fraction of a circle. We'll be applying this more in mensuration, and you see how interesting it is. Now, after this, I think we can go to the properties. Like I said, there are 3 things you should observe or you expect. Be inquisitive and look for them. 1, diameter. There's a diameter. Maybe there's a diameter. 2, maybe there's a chord, right? And 3, tangent. You know a tangent? A tangent touches a portion of a circle. It touches the circumference of the circle at a point. It doesn't cross the circle. It touches it. When you see a tangent, there's a property we are also going to look at. So quickly, let's go to the properties. Property number 1. Let's go to the properties. Property number 1, as you can see here, right? I'll do the sketching myself for you to see how it was done and see the logic behind it. Good. This is my circle. Take it like that. Is it nice? Good. That's my circle. So let's start the process. This is a chord. This is a chord. How we agree from what we said. And watch what I'm doing. I'm drawing a triangle subtended by the chord. When we say subtended, you can see the word from up here, subtended. That means it is it is carrying or it is holding the angle. That's what it means. It's holding. So the angle sits on it. It sits on that line we refer to. So this line, this chord, is subtending the triangle. So you can say the triangle is subtended by the chord. Can you see that triangle? It is subtended by the chord. That means from one point of the chord to the other point, and makes the triangle at the circumference of the circle. Take note. I'm going to draw another one. Watch that one too. Good. The second triangle I'm drawing is also subtended by the same chord, formed at different point of the circumference. Do you see it? So it's not coming from a different point. Let me draw a third one. The third triangle I'm drawing is also subtended by the same chord. The chord has not changed. Also formed at the circumference. So this triangle is at the circumference. This angle is also at the circumference. That angle is also formed at the circumference. Now, in everyday life, let's use 100-meter race. We all start a race from here. This is a 100-meter race. From here to here is 100 meters. This Usain Bolt, right? And this yourself, you the person listening to me. You are the person in the middle. And myself, I'm also here. So we are three running. This is a 100-meter race. 100 meter. Usain Bolt finishes 100 meter. We know he'll be first. Please don't argue. He'll be first. Second person, you. I'm sure you'll be last because I'll run faster than you. So I'll be second. I'll be the second person. Usain Bolt is first. I'll be second. And you, the person watching me, you'll be first. You'll be third. Right? Please don't bring yourself. If you want us to go for competition, you can make an arrangement that you do so. Now, at the end of the day, the most interesting thing or the most important thing is that we all finished the race at 100 meters. True or false? That's it. It's true. Just that one was first, one was second, one was third. So, what do I mean by that? By observation with your eye, you may think that one of the angles is bigger than the other or longer than the other. But in reality, because it's drawing, that's why in your books it is written, not drawn to scale. Diagram not drawn to scale. You get the picture? That's the essence of that statement. So, but in reality, we've all completed the 100-meter race. True or false? It is. So, if I start from here, I end my 100 meters. You also start from here, you end the 100 meters. Usain Bolt also start, he also ends his 100 meters. No one has gone 200 meters. We've all gone 100 meters. True or false? In principle, therefore, these angles are equal. So if this is 30 degrees, this must also be 30 degrees. That must also be 30 degrees because we all started from the same chord. This in everyday life principle is practical. So you look for a chord and recognize that two or more angles are subtended. That means sitting on the same chord, finishing at the same point. None of them will be greater than the other. They are equal. Does it make sense here? That is it. So recognize a chord. Sometimes the examiner does not draw the chord for you, but I can see that the two or the more, the 2, 3, or 4 angles are sitting, coming from the same point. If you see 2 points and they're coming from the same point, connect. You dash it to connect to form your own chord, and it makes sense. It applies in that sense as well. Simple as A, B, C. I hope you are convinced. So, if you want to put the statement, which you don't need anyway, angles subtended by the same chord formed at the circumference of the circle are equal. Full stop. Are you okay now? Thank you. I can see a chord here. For what we have done earlier, I will not explain